morning all. This is Dr. D. Khalandar Basha working as Associate Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the I/O ports, input-output ports in 8051 microcontroller under the course Microprocessor and Microcontroller. The slides are prepared by referring the textbook The 8051 Microcontroller by Kenneth J. Ayala, Singh's Learning. So 8051 microcontroller have 4 input-output ports, each of 8-bit, which can be configured as input or output port. So in total, 32 input-output pins allow the microcontroller to be connected with the peripheral devices. 4 ports, each port is 8-bit size. So total 32 bits we are having for I/O port configuration. Pin configuration, the pin can be configured as 1 for input and 0 for output. So to configure any particular port, first we have to write 1 for that particular I/O port. To configure as output port, we have to write 0. Input output pin, all the circuits within the microcontroller must be connected to one of its pins except a P0 port because it does not have pull-up resistors inbuilt. Input logic, logic 1 is applied to a bit of the port register. As we have discussed, the 8051 microcontroller is consist of 4 ports, namely port 0, that is port 0.0 bit to port 0.7 bit, that is 8 bits. The pins on 8051 microcontrollers are pin number 32 to 39 corresponding to port 0. For port 1, the port pins are port 1.0 to port 1.7. The pins on 8051 microcontroller are pin 1 to pin 8. The port 2, that is port pins are port 2.0 to port 2.7, and on 8051 microcontroller we can see this port on the pin numbers 21 to 28. Port 3, the port pins are port 3.0 to port 3.7, on the microcontroller pin number 10 to 70, and each port is consist of 8 port pins. Example, if you are named as port 0.x, so the x indicates the port pins, like x maybe takes 0 or 1 until 7. Similarly, for port 1.x, port 2.x, port 3.x, port 0.x0 indicates the bit 0 of port 0, which we can take as LSB of port 0. If you are referring P0.7, it is the bit 7 of port 0, which is MSB of the port 0. These 8 bits form a byte from port 0.0 to port 0.7. Each port can be used as input-output port, which is a bidirectional one. We can configure as input port or we can configure as output port. Port 0 is called true bidirectional ports as it floats, that is a tri-stated when configured as input. Port 1, 2, 3 are called quasi bidirectional ports. In port 0, input pin logic 1 is applied to the particular P register. For port 1, the output affect a transistor turned off and other pins remains connected to the power supply voltage over a pull-up resistor or high resistance. The figure shows the port 0 structure, which is consist of a latch, and the output of latch is directed by using a tri-stated buffer with the control pin as a read latch. For latch, the internal bus is connected to the data input, write signal is connected to the select line. When we are fetching the data flow direction from the port to the microcontroller will be handled by the read bit, which is connected to the tri-state buffer. As this is a multiplex signal, either we are passing address or data information or port information. So this multiplexer is used for selecting either address information or the IO port information by the control signal. The multiplexer output is connected to the transistor. This transistor will be connected to the ground whenever we will get the multiplexer output is equivalent to 1. Because the NMOS transistor will be on. The NMOS transistor will be on if the control signal for the gate signal is equivalent to 1. The output of this transistor circuit connected to port 0. Here X indicates this is applicable for all the port pins, that is port 0.02, port 0.7. So like these structures, we are going to have total 8 structures. The port 0 can be configured as normal a bidirectional IO port, or it can be used for address or data interfacing for accessing the external memory. When the control signal is 1, the port is used as address and data. When the control signal is 0, the port can be used as normal bidirectional IO port. If the control signal is 0, when the port is used as input port, 1 is written to the latch. In this situation, both the output MOS transistors are off state. Hence, the output pins floats. This high impedance pin can be pulled up or low by external source. So when the control signal is 1, it is going to select. When the control signal is 0, the output of this AND gate is 0, and this data which you are passing, that will be makes this transistor on or off state. So when you are configuring the port as input port, the data which you are going to be write as 1. So when you pass this signal as 1, so this latch also will be going to be connected to ground signal. So when the port is used as output port, 1 is written to the latch, gains turned off both the MOSFET and causes the output pin to float. An external pull-up is required to pull the output to 1. But when 0 is written to the latch, the pin is pulled down by the lower MOSFET transistor. Hence, the output becomes a 0. Resistors are required here. So, what is the control value we are considering? When the port is used as output port, 1 is written to the latch. When you pass 1, the Q bar is going to be 1 and Q is equivalent to 1. As this one is 0, so the output of multiplexer is equivalent to 0, which will make the NMOS transistor is also off state. For selecting this, the control signal is equivalent to 0. As the control signal is equivalent to 0, the output of AND gate is equivalent to 0. So both NMOS transistor is going to be on state. So in that case, we have to connect the external resistance. This is for when we are writing 1. Suppose if we are writing the data is 0, for the output port, when you are writing the data is 0, the Q is also 0, Q bar will become 1. This control signal, we will write the value as 0 for selecting this data. So as the control signal is 0, which will act as a select line for this multiplexer, which is going to provide the Q bar. So the Q bar value is 1. For this AND gate, the control signal is 0. So the output of this control signal is equivalent to 0 for this MOSFET. So as it is a NMOS transistor and 0 is driven to the gate terminal, so this transistor will be goes into off state. As the gate of the NMOS transistor is connected to 1, this NMOS transistor is going to be in on state. When this NMOS is on, the output terminal is pulled to ground. That means this output port is going to be connected to 0. So when the control signal is 1, so now we will see the write operation also similarly. When we want to write the data, when we are going to write the data, so the control signal is 0, as this one is 0. Okay, already discussed. Next, when the control signal is 1, this control signal will select the multiplexer from these terminals, which is nothing but address and data information. The same address and data information we are going to send to the output of this AND gate. If the corresponding bit, let us assume if address or data bit is equivalent to 1, the output of this AND gate will become 1 AND with 1 is 1. Here also we will get the output of the NOT gate is 0, 0 will be passed to here. As NMOS is connected to the 1, the gate terminal, so NMOS transistor is going to be in on state, and the gate terminal of this NMOS transistor is 0, so this transistor will be goes to off state. Now your output terminal, that is port 0.x, will be connected to VCC. The data which you want to write is 1, so as it is connected to 1, so this is also at logic 1 state. So when the control signal is 1, the address data bus controls the output driver MOSFET. If the address or data bus is 0, the second case will consider if the address or data bit is equivalent to 0, first we are making the control signal as 1, so it is going to select this data line. If the data value is 1, the output of MOS transistor inverter is 1, so 1 will be passed to the output of multiplexer, which will make the lower NMOS transistor is in on state. In the upper NMOS transistor is driven to the output of AND gate. So here the address and data input is 0, so the output of AND gate is 0, so this transistor will be goes to off state, and the output, that is P 0.x, will be pulled to ground, nothing but the port is going to have 0. So if the address or data bus is 0, the upper MOS transistor is in off state and the lower MOS transistor is in on state. The output becomes 0, and if the address bus is 1, already we have discussed, when the address bus is 1, the this NMOS transistor will be in off state and the upper transistor is going to be on state and pull the output terminal to VCC, which indicates the output is at logic 1. Hence, for normal address or data interface for external memory using port 0, no pull resistance are required, only for address and data information. But when it is using as a IO port, we have to connect one external resistance. The next one is port 1. The port 1 pins have no dual function. This is a dedicated port we can have. Therefore, the output latch is connected directly to the gate of lower FET, which has an FET circuit label internal pull-up as the active pull-up load. Used as input, a 1 is written to the latch, turning the lower FET off. The pin and the input pin buffer are pulled to high by the FET load. An external circuit can overcome the high impedance pull-up and drive the pin to 0 or leave the input high for a logic 1. If used as output port, the latches containing 1 can drive the input of external circuit through the pull-up circuit. So now the circuitry for port 1 is shown in the figure. So let us consider we want to configure the port pin as input port. Then the data will be passed on these lines. This will be given to the microcontroller through this tri-state buffer. So when we are reading this data, the read signal pin makes the tri-state buffer on, so that the data which is present here, that will be sent to the output of tri-state buffer and it is given to the internal bus of microcontroller. So this is to configure the 8051 port 1 as input port. where we can read the data from port P1.0, P1.x to the microcontroller. Suppose if the microcontroller wants to configure this particular port as output port. In that case, the data will be sent onto the D line. So let us consider for the port I want to write the data as 1. So the Q is going to be 1, Q bar is going to be 0. When Q bar is going to be 0, the M1 transistor will be in off state, because of which the port 1.x will be pulled to VCC. Pull to VCC means the logic at this point is 1. So our intention is to pass 1. At the output side also we are going to get as 1. Suppose if the data whichever you want to pass to the port is 0, in that case the microcontroller will pass the 0 data. So Q will become 0, Q bar is 1, and this Q bar is connected to the NMOS transistor M1. As 1 is given to the gate signal, the NMOS transistor is going to be in on state. So now for the port, it has two paths. One is towards VCC through the load, as well as this is connected to the ground through M1 transistor. Out of these two, the M1 transistor is going to give very less resistance, so the output port will be connected towards ground. That is nothing but the port 1.x is going to contain logic 0. Our intention is to write the data is 0. So at the output side also we are going to get the data as 0. So if 0 is written to the latch, the lower FET on and the pull-up is off, and the pin can drive the input of the external circuit to low. To aid in speeding of switching times with the pin is used as output, the internal FET pull-up has another FET in parallel with it. The second FET is turned on for 2 oscillator time period during a low to high transition on the pin. The arrangement provides a low impedance path to the positive voltage supply to help reduce rise time in charging any parasitics present in the external circuit. We know that the parasitics will cause more amount of delay. Coming to the next port, that is port 2. The port 2 is having a dual functionality. That means the port 2 we can use for two different functionality. One is the port 2 can act as IO port, that is input output port, as well as the address for the external memory. Port 2 latch remains stable when port 2 pins are used for external memory access. Due to internal pull-up, there is a limited current driving capability. When 16K external memory is connected, a 16-bit address is required. Lower byte is carried out by port 0 and the higher byte of the address is carried out by port 1. As we know, the 8051 microcontroller, the address bus is 16-bit size, B0 to B15, and the data bus size is bit 0 to bit 7, that is 8 bits. So these signals are multiplex signal. So we are going to have AD0 to AD7, which is consist of both address and data information, whereas from A8 to A15 it will contain only address information. These A8 to A15 are connected to the port 2, whereas address and data lines, these are connected to port 1. So port 0. So when 16K external memory is connected, 16-bit address is lower byte address is carried by port 0 and higher address is by port 2. Since the data is 8-bit, only address is carried in this port, whereas port 0, it is consist of both address as well as data information from AD0 to AD7. When it comes to port 2, it is going to hold only address information, that is A8 to A15. However, the port 0 or port 2 are multiplex signal. That means it will have a dual functionality. It will serve as input output port Apart from that, port 0 will act as address and data lines, and port 2 will act as only higher byte of the address lines. By default, this port is an output port. To make this port as input, the port SFR latch buffer should be set all to ones. The figure shows the port 2 of 8051 microcontroller. Here we have a latch. The latch output is connected to the multiplexer, which is going to control the MOS transistor, either it is on state or off state. Here we have a control gate, which is having the control signal to select either address information or not, to make this pull-up transistor on or off state. Now, when the control signal is 1, the output of this select line is nothing but the address information. Here also this multiplexer will select the address information. This address information will be given to the NMOS transistor. Let us assume if the address bit is 0, the output of this multiplexer is equivalent to 0, the output of this NOT gate will become 1, which will make the transistor NMOS on state. How about this AND gate? As this AND gate is driven with the address lines, and this address lines is having 0, here you will get the output of AND gate is equivalent to 0, which will make the pull-up transistor in off state. As the NMOS transistor is on, the pull-up is connected to ground, so the address which we are intended to pass as 0, that will be reaches to port 0. Similarly, let us consider if the address information is 1. If the address is 1. For passing the address line, we are going to select the control signal as 1. So the output of this AND gate, 1 AND with 1, I'll get as 1. And this multiplexer will select the address information with the value as 1. So the output of NOT gate will become 0, which will make the NMOS transistors off state. When the NMOS transistor is off state, the port 2 will be pulled to VCC, which will make the port pin as 1. So this is for port 2 to functionate as address information. The second case is the same IO port we want to use as a IO port. In that case, the control signal is equivalent to 0. When the control signal is equivalent to 0, the output of AND gate will become 0. Now, this multiplexer is going to select the output from this latch. Now, we will say, let us consider the processor wants to write the data as 1 to the port 2. So, now this data is equivalent to 1. So, this will be passed to the latch, which will make the Q is equivalent to 1. As the control signal is equivalent to 0, this 1 will be passed to the output of multiplexer, which is equivalent to 0. Which will make, as the NMOS transistor is driven to 0, this is going to be in off state. As we have a pull-up network here, this will be connected to a VCC. Because here 0 is passed, what happens to the pull-up transistor always on. Now, as port 2.x is connected to VCC, the data which we are writing to this port will become 1. Our intention for this one is to pass 1 for the port. So, 1 is reaching to port 2.x. The second case is, let us consider if the data which the microcontroller wants to write for port 2.x is equivalent to 1. In that case, the output of, previously we considered 1. Yes. Now, we will take the data input is 0. So, let us consider the microcontroller wants to write the data as 0. So, this 0 will be passed to the output of latch, that is Q is equivalent to 0. As the control signal is equivalent to 0, the data on this Q will be selected to the multiplexer. So, the output of the multiplexer is equivalent to 0, which will give us the NOT gate output is equivalent to 1. As the NOT gate output is equivalent to 1, the NMOS transistor is going to be in on state. However, the pull-up transistor, which is PMOS, is driven with 0. This is going to be always in on state. Now, this port 2.x, it is having both the path towards VCC as well as towards ground. Out of these two, the NMOS transistor will have low resistance, so the port 2.x will be pulled to ground, which will make the port is at logic 0. Our intention is to pass 0 for the IO device. So here 0 is passed to the IO device through port 2.x. The next one is port 3. For port 3, in terms of hardware, this will resembles to port 0 only. The difference between a port 0 and port 3 is the port 3 pins have a pull-up resistor inbuilt, whereas port 0 we have to connect external pull-up resistors. Port 3 individual port pins can be programmed as input or output port. Each port of port 3 can be programmed for input or output operation alternating functions. All the port 3 pins serves alternative functions according to the hardware signals and interfacing. The port 3 also will have dual functionality. The alternative functions can be activated only if the port 3 bits return to 1 in their position. The port 3, that is from bits port 3.0 to port 3.7, the alternative functionality which are going to be defined are tabulated. Port 3.0, it will act as IO port. Apart from that, the special function it is going to have is, it will act as a RxD signal, where this RxD signal is a serial data for receiving the data. So it will act as serial input data. Port 3.1 is a TXD line, which indicates the transmit data, so which is nothing but serial output data. So through TXD line, the data will be transmitted. Port 3.2 will act as INT 0 bar, which is a external interrupt 0. Next, port 3.3 is INT 1, which is external interrupt 1. Port 3.4 is T0, which is the external timer 0 clock signal. P3.5, which is T1, which will act as external timer 1 clock signals. So these two provides the clock signal for timer 0 and timer 1 respectively. Port 3.6 is write bar, which is external memory write enable. Whenever the microcontroller wants to write the data to the external memory, this write bar signal goes to 0. P3.7, in that case, the signal is signifying as RD bar, which indicates it is the external memory read enable signal. The block diagram of port 3 is shown in figure. Here you can see the internal pull-up resistance is present by default for port 3. So this port 3 we can use for multiple functionalities. One is it will act as a IO port. The second one is the functionality which you are tabulated here, like RxD, TXD, INT0, INT1, T0, T1, read bar and write bar. So let us consider, if this port wants to read the data from this particular port, in that case, we are going to enable the read signal. When read is equivalent to 1, the data which you are passing on port 3.x will be flows through this buffer. Again, once it comes to here, we have here it is a read input control activated tri-state buffer. As read signal is equivalent to 1, the data will be sent to the microcontroller, as well as you can store the data in the latch also. When the read signal is equivalent to 0, this tri-state gate will act as open circuit. Then there is no link between the output terminal, that is port pin, to the microcontroller. Now next we will see the next functionality where we have to program this port 3.x as output port. When we make this port 3.x as output port, the data which you are writing, either you can directly send or you can store this one in the LAN, right? So let us consider our intention is to pass 0 to the port signal. Then the output is 0 here. This 0 makes the NOT gate operation, either it is 1 or 0 state. So now the value which it is going to give the alternating output signal, whether this value is equivalent to 1 or 0, that will decides the NAND gate output. So for IO operation, this value we will write as 1. When we will write this data as 1, 1 AND with 0 is 0, 0 complement is 1. So when we are having 1 to the NMOS transistor, so the NMOS transistor will be on, which will make the port 3.x will be connected to the ground. Even though you're having a pull-up resistance which is connected directly to the VCC, but it will offer more resistance compared to the on resistance of NMOS transistor. So now the port is pulled to ground, so we can say the logic 0 at port 3.x. So our intention is to write 0 to the port. Here also we are receiving the data as 0. Let us consider if the data which the port you want to write, that is port 3.6, as 1. Microcontroller wants to write the data as 1. So this 1 will be passed to the D latch. So the Q is equivalent to 1. The Q signal is given to this NAND gate. So already the alternative signal will be pulled to 1. So 1 AND with 1 is 1. 1 complement is equivalent to 0 because it is a NAND gate functionality. 1 AND with 1 whole complement. 1 AND with 1 is 1. 1 complement is become 0. When 0 is connected to the gate of the NMOS transistor, so the NMOS transistor will be goes into off state. When the NMOS transistor is in off state, the output P3.x will be connected to the VCC by means of pull-up resistance. So because of that, the port 3.1 we can see at logic 1 due to connecting to VCC. The microcontroller wants to write the data as 1 to the port. Here also we are getting the data as 1. So this is the sessions about the ports which are existing in 8051 microcontroller. As we seen in 8051 microcontroller, it consists of ports, namely port 0, port 1, port 2, port 3. Each port is 8 bits. So total 8 into 4, 32 IO pins are existing in 8051 microcontroller. So port 0, port 1, port 2, port 3, the internal structure we have seen for each and every port. Few ports it is having dual functionality. The port 0 will act as both IO port as well as address and data information. Port 1 is a dedicated port, whereas port 2 will act as IO port as well as it is going to hold the higher byte of the address lines, that is from A8 to A15. Whereas port 3 will act as IO port. Apart from that, it is having other signals like RxD, receive data, TXD, transmit data, INT 0 bar, INT 1 bar, external interrupt 0, external interrupt 1. The next one is the clock signals for timer 0 and timer 1 from the external. Apart from that, a read bar and write bar control signal. So with this, I'll end the session. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.